All right, here are the 7.2b notes. So on the 7.2a, we crossed out a lot of those homework problems because we didn't talk about the other types of functions. So here we go. We know trig functions of sine, cosine, and tangent, and we have used a mnemonic device of SOHCAHTOA to help us determine those trig functions and the relationship between the sides and the angles. Okay, their inverses are also functions that we'll use sometimes to model situations, especially in Unit 8. But those inverse functions have the names of cosecant, secant, and cotangent. So it's sometimes tempting to think, well, cosine goes with cosecant and sine goes with secant because of just the way that the letters sound and the starts of the words. But you have to remember that they are opposites of one another. So if it's sine and cosecant, so sine theta goes with, whereas the inverse of cosecant, CSC of theta, the cosine of theta is inverses with secant of theta, and cotangent, well, that's the easy one, right? Tangent of theta is inverse with cotangent of theta. Okay, so we're talking about three new functions, and what they mean by inverse is they're just the reciprocal. So if sine is normally opposite over hypotenuse, the cosecant becomes the hypotenuse over the opposite. Okay, and we're still in relationship to the angle. The secant, if adjacent over hypotenuse is cosine, then we're going to take the hypotenuse over adjacent, or reciprocate that for the secant. And tangent is opposite over adjacent, so cotangent is adjacent over opposite. Okay, so we just reverse. It doesn't really make a nice word, so we can't use a mnemonic. So essentially we refer to the SOHCAHTOA and then flip it. Okay, so use reference angles to find the value of the trig functions. Now we are using exact values, which means that we're not going to use calculators and we're going to leave our answers in radical form. Also, we're going to use our 30, 60, 90, and 45, 45, 90 triangle relationships. So maybe we want to refer to that. So the 30, 60, 90, sorry, my triangle's not working so well. Remember when I have a 60 and a 30, if this short side leg is x, the hypotenuse is 2x, and the long side leg is x root 3. If I have a 45, 45, 90 triangle, then I have these two sides are both the same relationship, and this is x square root 2. Okay, so we are going to find the exact value for sine and cosecant of 120. Now remember, these are reciprocals of one another. So if once I find sine, I can easily find cosecant. Okay, so what I'm going to do first is I'm going to start out by drawing in, whoops, sorry, I was trying to get a grid here. There we go. That's good. All right. So the sine of 120 degrees. So I need a reference angle of 120. So we start in the initial side and 120. Remember, this is 90 degrees. So 120 is going to be over here. So this is theta is equal to 120. Well, if I want to find the sine of that angle, we're going to use the reference angle. Okay. And so the reference angle is the distance, recall, to the x-axis. So that's this angle right here. That's my reference angle. So first, we need to remember that to find the reference angle in quadrant 2, we take 180 degrees minus theta. So in this case, it's 180 degrees minus 120. So the reference angle is 60 degrees. So what we're going to do is we are actually going to drop a perpendicular line to the x-axis. And what happens is this creates a right triangle. Maybe. There we go. A right triangle that's a 60, and this is a 30. Okay, and so what I know is that if this red angle is the angle that I'm referring to, this in a 30, 60, 90, this is the short leg, this is the x root 3 leg, and this is 2x as the hypotenuse. So if I want sine is going to take the opposite over the hypotenuse of the angle 60 in this case. So what I'm going to yield, or what I'm going to substitute, is I know the angle is 60 degrees. So I'm going to say sine of 60 degrees is equal to opposite over hypotenuse. So opposite of 60 is across the triangle. I need a different color. I don't know why I'm working so small here. Sorry about that. So I'm going to go across the triangle. There's my opposite, and my hypotenuse is 2x. So I'm going to take this x root 3 is opposite over hypotenuse is 2x. Well, what ends up happening is your x's can cancel, and so the exact value is equal to the square root 3 over 2. That's the sine of 60 degrees. Okay, the cosecant of theta is the reverse. We take the hypotenuse over the opposite. So I'm just going to reverse it. So the cosecant of 60 degrees is equal to the opposite, or the hypotenuse, which is 2x over x square root of 3. So I'm reversing it. Now again, the x's cancel, but remember what we did in unit or section 1 where we had a radical in the denominator. That's not okay. So I'm going to rationalize the denominator, and I get 2 root 3 over 3. Okay, now that was for the reference angle, but the reference angle is in the same position as the standard angle of 120. So once I find out that the reference angle, sorry, and I didn't actually write that here, is 60 degrees, then that means that the sine and the cosecant of 120 are the same value. So therefore the sine of 120 is equal to the square root 3 over 2, and the cosecant of 120 degrees, sorry, that was degrees also, is 2 square root 3 over 3. And so this is the answer that we were looking for that question. Okay? It's a little confusing, but it does get easier as we do some examples. Okay? Now, we're going to do number 2, and we're going to find the exact value of tangent and cotangent of 315 degrees. So the way we do that is the same way that I started before, and so I'm going to draw in a coordinate plane. Shift it over a little bit, maybe. Okay, so 315 degrees. Remember, this is 0, this is 90, this is 180, this is 270. So 315 degrees, because this is 360 as well, is going to be over here in quadrant 4. So we're going to draw, starting with my standard, or in my initial ray, I'm going to rotate around, and I know that I'm somewhere between 270 and 360. So this is my 315 degree angle. But I want to know what the reference angle is, and the reference angle is to the x-axis. So this is the theta I'm going to refer to. Okay? So in reference angle in quadrant 4, the measure of reference angle is equal to 360 degrees minus 315, which means we're going to use a 45 degree angle. Okay, so that means we're actually, and I'm going to erase this for a second, we're going to actually use this as a 45. Now what we're going to do is the same thing we did before. We're going to draw on a triangle to the x-axis, and it's going to be a, oh no, I have the eraser, sorry guys. We're going to draw in the triangle to the x-axis, and so this is now a right triangle. Well, if you have an angle of 45, that means that this is going to be a 45, 45, 90-degree triangle. Okay? Think about the sides. This is a positive x value because we're going to the right on the x-axis, and this is a negative x value because I'm going down from the x-axis. So I have a positive x and a negative x, and then the hypotenuse, because it is a radius, is always going to be positive at x root 2. Okay, so the radius is x root 2. So now we're referring to this angle here. That's my reference angle for tangent of 45 or 315. Well, so we're going to do tangent of 45 degrees. Let's do that first. Tangent is opposite over adjacent. So I'm going to write that over here. So tangent of angle is opposite over adjacent. So we're going to substitute in the opposite of the 45. So I go across, and it's negative x over adjacent, which is next to, is positive x. Negative x over positive x is just negative 1. For cotangent, it's the reciprocal. So cotangent of theta is equal to the adjacent over the opposite. Okay, so I'm going to say the cotangent of 45. Now we're still referring to that same. So the adjacent is this positive x, but the opposite is the negative x. So all we did was reciprocate. So I had a negative over a positive, and now I have a positive over a negative, but it still gives me a negative 1. So now that directly relates to the 315 degree original angle. So tangent of 315 degrees is equal to the same as the tangent of 45. So this was negative 1. And tangent of cotangent, my mistake, of 315 degrees is also negative 1. Okay, and that was the answer that we were looking for. Okay, now one thing that's going to be something to be cautious about is our signs. Okay, so we have kind of this mnemonic, or an acronym, I can't remember which one it is, to help us remember what the signs should be in each quadrant. Okay, so that's going to help us address this quadrant of what quadrants is cosecant theta greater than 0 or positive. That's just another way of saying, saying positive. Okay, so here I have, I'm going to draw in another grid over here. I need this. So we have the 4 quadrants. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Quadrant 1, we're going to use A, S, T, and C. The way that what this means is that in quadrant 1, all functions are positive. Okay, so whether it's sine, cosine, tangent, or it's reciprocal or its inverse function, all of the functions are positive. So hence the A is the all. Okay. In quadrant 2, only sine and its inverse are positive. Okay, so the S. So we would say sine theta and its inverse of cosecant theta are positive, which means that cosine and secant, let me change my colors here, cosine theta and secant theta are negative, and tangent theta and cotangent theta are negative. So the fact that this is an S means sine is positive. This is an A, all are positive. Okay? Then in quadrant 3 is a T. That means that tangent and cotangent are positive. Okay? So again, we have this T or tangent and its inverse, which means that sine theta and cosecant, so the two inverses, are negative, and cosine theta and secant are negative. Okay? And then in quadrant 4, so we have sine, tangent, and this is C. The C is for cosine. So cosine theta and its inverse of secant theta are positive in quadrant 4. But that means that sine theta and its inverse, cosecant theta, and tangent theta and its inverse, cotangent theta, both of those are negative. So we're looking at this C and C. So the way that we remember which functions are positive in which quadrant, all students take calculus. Okay, so if we can remember that all students take calculus, then we're going to remember which quadrant is positive for which function. So if I look at cosecant, cosecant is greater than 0 or positive. Cosecant theta is the inverse of sine. Sine theta. Sine theta is positive. Sine theta is positive in quadrant 2. Well, quadrant 1 and in quadrant 2. Which means that cosecant is also positive in quadrant 1 and 2. So the answer is 1 and 2. Since sine is positive in quadrant 2, cosecant is its inverse, that means that cosecant is positive in quadrant 2 as well as quadrant 1 because all functions are positive in quadrant 1. Okay, so that's how you would address that question. I do want to go through maybe one or a couple of the homework questions. So remember, these we did actually yesterday or the last time we did assignments. So we already did those, drawing the reference angle. Okay, so for 7, 8, 10, 11, going down 7, 8, 9, 10, 11, 12, those are going to be directly related to what we did in question 1 and 2. First, find the reference angle. Use your special right triangles to help you out. So remember, your special right triangles are the 30, 60, 90, where this is x, this is 2x, and this is x root 3. For the 45, 45, 90 triangle, this is x, and this is x root 2. This is the 90 and this is the 45 degree. Okay, and then when you go ahead and you answer these questions down here, what quadrant is tangent greater than 0, cosecant less than 0, and which quadrant are sine and cosine negative. Okay, so all you're going to do is you're going to refer back to this organizer right here to answer those. Okay? Happy trig.